Okay everyone, welcome back. This demonstration for this video is to explain how lofts are created in OnShape. This is the basics of Loft. There's more to it than what I'm going to kind of show, but at this point you're going to use this video as reference for when you need to do it. And I have three examples here that you can kind of, we're going to take apart and take a look at. So the first one that you can see here, you can see kind of a fairly bizarre looking shape. I actually have two hexagons, and then I have specific vertices being translated. So I have like this point here being converted down to this point here, right? And then when you do that with all six sides, you create this rather interesting shape. So we could use this to create various twists for turbine blades or abstract shapes or ergonomic shapes and things like that. Basically, you're transforming one two-dimensional sketch over into another two-dimensional sketch, and it doesn't necessarily have to be parallel planes. This specific one, the plane that this hexagon is on a parallel plane in reference to this, separated by I believe 10 inches. So I want to talk about how to create planes parallel to themselves and so forth. There's ways to do it in angles as well, so if you needed an angle in reference at 45 degrees to this plane, we can do it. I'm not going to show you that in this video because that would just be too many things in one video and it would make things difficult to look up in the future. So let's just kind of unpack what we have here. So obviously I'm going to turn on my plane so you can kind of see the datum planes, the ones that we get by default. And as you can see, one of the sketches, sketch 1, is actually on the top plane. That's just a hexagon. I made it 1.5 inches in side width or side length, right? Because it's a hexagon. It's really not in a specific orientation where you can define it as width or height. But one of the sides is 1.5 inches long. And if you take a look at how I've arranged the sketch, I have vertical sides on one sketch, and then I have horizontal sides on the top sketch, but they're the same hexagon. The only difference is one is rotated, right, to have a face being horizontal versus vertical. I also have it set to 10 inches apart. If I go into the loft, the question is, what are the faces that need to be lofted? So all you do is in the profile area, you select the two sketches that you want to have conjoined, and then at that point, I actually checked match vertices, and when I do that, you can see I've selected this point to match this point, right? A vertice is the intersection of two points, typically, that make up, let's say, a planar surface, right? Two edges, so that's your vertice, that's your other vertice. I could modify this, so if I take away sketch 1's vertice, right? I already have sketch 2's, and I click this one, we'll get a extreme twist because this line is automatically brought over to here. Every other vertice follows that suit. If I want that to be less extreme, I could say this vertice goes down to this vertice, and as you can see that this loft is less of a twist, right? And so that's just one example. I didn't construct this exactly in the video. I want to kind of go over to another example here, just to kind of show. I have a square, right, on the top plane. That's a square shape right here. And then I created a parallel plane to the front over here. And at a specific height, right, I brought up that square and I kind of rotated it 90 degrees. Okay, and after that, I did the exact same operation. So you can kind of see, if I were to open up the loft properties here, I have face 2 being translated to face 1, normal to the profile. So it's going to come out of the profile and in normal to the profile as if it were to start being extruded. If I change this option to tangent to profile, you can see how it comes tangent to this profile and sweeps outwards and ends tangent to the other profile. So if I say OK at this point, I get an entirely different shape and I get this kind of point. So the question is, like, why would we need to do this? This is obviously just a modeling technique, so you can obviously apply this to anything. It's like, why would you need to use a screwdriver? There are plenty of situations, but there are a variety of abstract scenarios that we're not just going to go through. So This is just to explain kind of how these shapes would be created for when you need an issue or some sort of modeling technique where like I need to blend this surface over to this surface. It could be for making a handle, a water bottle, an ergonomic shape, and so forth. So due to the fact that I want to keep this video pretty short, I'm going to skip explaining loft example 1, but one thing you can see here is I have an octagon and a triangle being lofted. So when the sides don't necessarily match, you do get some bizarreness, and you could say match vertice, like this corner touches this corner, and it would probably modify this shape. But this is an example of when I have a 3-sided going into an 8-sided. It's obviously not an odd to an odd or an even to an even, so you're going to get kind of a bizarre looking shape. But, you know, for a scenario where you would need this particular geometric shape, it works for you, right? So this doesn't really serve a purpose other than to explain it, but I didn't do anything special with the loft. I have two faces, a triangle and an octagon, separated parallel by distance, and then lofted together. But it's fun to play with this, even if you don't really know what you want, just to see what you can get, right? So that's kind of what I did in preparation for this demonstration. So I'm going to quickly do one here, and I'm just keeping an eye on the time. I'm about 5 minutes in at this point. 6 minutes actually, and I'm going to just do loft example 4. Right? I don't have a particular reason to have these, so that's why I'm just giving them these names. They're logical, they make sense for future reference and so forth. So here's how I would do it. First, I'm going to create a sketch on a top plane, so I'm going to click top. It doesn't have to be the top, it could be any of these planes, right? You need to obviously decide that when your situation arises. So I'm going to choose a polygon at this point, just to replicate. I'm going to do something that you already saw constructed. So at this point I'm going to create, let's say, the diameter of this polygon, and then I'm going to click a specific point. Right now there's no sketch line determining where this clicked. And then when you move your mouse horizontally, you can create the number of sides. So I'm just going to keep it simple. Let's just do a pentagon at 5 sides. And then I'm going to not dimension the diameter of this pentagon, but actually the side, just because, and I'm going to make it 1 inch, which obviously conforms everything. So as you can see, we have a polygon on the top plane. I'm just going to say OK. All right, so that's part 1 of the ingredients. I'll make a parallel plane to the top plane. So if you right-click on the top plane on the left-hand side in the feature tree, you can then click Offset Plane, and then it's going to create a new plane, right, at the offset distance that this is specified at. So if I want it to go up 6 inches, I would put 6. I'm going to press Tab to show you the growth, right? It's going to project this plane over to here and define it as a new one. If you want to give it a different name besides plane 1, you could, just by clicking the pencil. For now, I'm not. I'm just going to click OK. So now I have plane 1 and top plane. So what I'm going to do now is click plane 1, it's highlighted, and then hit sketch. I'm going to normal to the top because it's the same type of plane. If this is confusing, you can hide the top plane and you can hide sketch 1 just so that you're not looking at it anymore. I like to know what sketch 1 looks like because I'm going to loft it to this. So I know that what I'm drawing on is not on this obviously plane. It's on the plane 1. Okay. So at this point, I'm going to create a polygon again. Center to the origin. The origin's keeping me positioned so that my parts don't separate, or I at least have a reference point to it. So I'm going to keep it on center at this point. And then at this point, I'm just going to create my hexagon, or we're going to do a pentagon. I will probably have my pentagonal point in the center, and you'll see how I'll do that in a minute. So I think I said 1.5, but I'm going to make it actually 2 inches at this point just to show a difference in size. Let's make it 2. And I want this point to actually be lined up with this vertical line. So once again, we can use construction lines to form this. So we're going to do center to the point of the pentagon, and then we're going to go origin to the vertical. The vertical stays vertical. We're going to make these construction lines by right-clicking and say construction. I actually just moved mine for some reason. I don't know how that happened. Oh, actually I rotated, that's why. Control Y. Let's go back to where we were. Top. I was right clicking and dragging by accident. So we're going to make this construction. Make this construction. I'm going to press D for dimension. And I'm just going to say that this is a 0 degree measurement, and it will automatically rotate this where I want it. Okay. And at that point, I probably can delete this dimension, and it'll stay. No, we'll leave it. As you can see, it's black. It's fully defined. So I'm going to go 2-sided pentagon to a 1.5-sided pentagon, and then they're actually rotated as well from each other. So I've built my ingredients. It doesn't have to be this technical. I'm just trying to make a different shape. And at this point, I have equal sides too. So I'm just going to click Loft, which is right here. And it's going to say, what are your profiles that you wish to loft? So we'll start with the bottom plane, sketch 1. And then we're going to loft it to sketch 2. And then at this point, we could start profile condition. We can change this to do normal to profile, right? We could also do match vertices. And the question will be like, what vertice do you want? I'll say, okay, I want this vertice to be lofted to this vertice, and you'll get that extra twist versus a direct side-to-side rotation. You say okay at this point. We can hide our planes because they kind of get in the way of us viewing what this object looks like, and at that point even the sketch if you don't want to see the sketches, right? So a bizarre shape nonetheless, but I just wanted to demonstrate once again how lofting can be done. You could do this with a perpendicular plane and you'll get that kind of curved surface just like you saw on example 2. Okay, so this just demonstrates how to do loft. I know I was fast, so you're going to have to like slow this down a little bit and look at where my mouse is clicking and so forth. And the best way to learn this outside of watching what I'm doing is just experimenting and trying this out, right? So maybe we shell this and now we have this weird vase that we print in clear resin and then give to somebody as a gift with an extruded base attached to it. Who knows? Maybe you make some funny looking megaphone, or you make this in some sort of abstract flower. But there's obviously mechanical reasons for why you would need to do this, but the first thing you want to do to learn how to create shapes like this is to just try it for no particular reason, just like I did here. I have no particular reason for this other than to experiment with this operation. So hopefully this was helpful, and I will share this video out as soon as I'm done processing it in YouTube.